All right, welcome. It's the Q&A live for this week. Today is August the 18th of 2023. I am your teacher. I am your algebra coach or your money made simple coach, or I could be your math made simple coach if you're in the younger grades. We are just tapping in here to give you a little extra value, a little extra resources to help your learner. If you're a student, to help you kind of push over the hump, refresh you on the things that we have covered during this week's session, and also maybe to give you some little tips on how to make things a little easier and smoother, simpler for you. Okay. So we're going to keep it real simple today. I have only really two topics I want to cover. I have some people finishing programs and some other people picking up next week. So sometimes, depending on the week, we have longer videos than others. But I really just want to cover two main topics. So let me go ahead and get to the first one. So if you're going through our Math Made Simple, meant for our younger age group, anywhere from about 7 up to 11 years old, so or so forth, you've been learning some different strategies if you've been hanging with us on how to add and subtract. And for parents, this is really a good time to experiment, right? We're trying to experiment and find out what ways work with your kid. You're going to find out if they're visual, if they're more of a mental math learner. You're going to have some tools available to you to kind of walk them through. And some of these tools, if they don't click or jive with your child right now, it might be a good use or a good tool for them in a couple years from now. You never know when they mature and they're ready to handle certain things. So you have to test it, right? And so one of the things we've been learning this week is something called how to add or subtract using what are called number lines. Okay, number lines are not going anywhere. So this is a pretty good thing to talk about because I've seen it pop up again when you get to the middle school age math classes, and it's really helpful for kids who are struggling how to do operations with negative numbers down the line. But that's just that. So anyway, I want to just go over a couple of things that they're going to be looking to do, and we're just going to see if it works with your young learner. And if you don't like it, it's okay. This is not the only method available to you to help them learn how to do bigger digit, 2-digit, 3-digit, 4-digit addition and subtraction, right? So let's say you're just starting with your young learner and we're doing a 3-digit number such as 200, excuse me, not 200, 316 plus, and we want to do, I don't know, let's break it apart. Let's do something like 445. Okay. Now, number lines can look a lot of different ways, but sometimes the visual really helps kids break things apart. We talked about the break apart method, I think it was last week, right? So if you have a number line, remember that's just a horizontal left and right line, and you can put different numbers and count by different amounts, right? You could count by ones if you're going to have really smaller numbers, but since we have such large numbers, 3-digit numbers, right? We want to count by larger intervals. So as I was showing in the video, that first number, if you're looking at addition, is always going to be on the far left when you're looking at most of these number line examples, right? We're trying to add 445 to 316. And so you want to give some examples. You can maybe have your learner draw and try to sketch their own one that could make sense, make a mistake and learn from it if they have to. But if you notice, 445 is really breaking things apart, right? We talked about this the week before, like 400 and then the number 40 and then the number 5. If you were to just break these apart into intervals like that, this could be a useful thing to do actually first before you try to actually count the number lines ahead. And so you can kind of see how, if you want to do this, you could say, okay, well, that's 416. It's going to be 316. This would be 416. And you can break it apart in different ways. I'm just kind of doing it this way to, I don't know, make my point, I guess. But eventually you're going to get out to 716 if you count by hundreds, right? And so when you see number lines, sometimes they'll do bigger intervals for the hundreds, and then they'll do smaller intervals when you get to the tens and the ones and so forth, right? So for example, if I'm trying to do 316 plus 445, I want to go all the way 400. That's going to be 4 units. 1, 2, 3, 400. And you could even say plus 400 at the top of that first hump to kind of show a visual representation, right? 445 is like 400 plus 40 plus 5. But when you see 40, that's counting by tens. So I want to do a very small, a much smaller interval when I get to the tens example. And I'm going to show how to go from here to here. I'm going to make that maybe 40 more. So I think that's 756. And so from here to here, we're going to show how that's plus 40 to your young learner. And that's going to bring you up to 756 if I did my math right. Okay. And then if you want to keep going a little bit more, it says plus 5. So you can actually, show the intervals in different ways. It's going to be kind of hard to see this, but 761, I believe, is where you're going to end up. And so showing the break apart with the number line can just be a really good tool. It can be an excellent tool. And it looks like you end up getting 761 when you do it this way. Okay. And so this is an example of a number line that you can create yourself. You can talk to your kid about how this works. I'll bring it up really close to the camera in case you couldn't really see it as well the way I was holding it before, and hopefully that makes sense. So I'm a big fan. Perhaps I did or did not make this super clear when we did the actual lesson earlier this week. I'm a big fan of break apart the number you're adding on the end into hundreds, tens, and ones, right? If it's a 3-digit number, that's going to be, in this case, 400 because there's a 4 in the hundreds place. It's going to be the number 40 because there's a 4 in the tens place. It's going to be the number 5 because you have a 5 in the ones place. So they can physically see we went 400 from the very get-go. 316 plus 400, that's 116, right? And then we only added 40 more. That took us to 756. Add 5 more, 761. There's a visual for you. Okay. One of the things we didn't cover a whole lot of is what to do with subtraction on the video this week. And so I wanted to touch on an example that has subtraction. I think you're going to see it on this week's online assessment a handful of times. So I wanted to cover it on the Q&A this week. Okay. So let's look at a subtraction example on the number line as well. Let's say we'll do smaller numbers for subtraction. Let's say you had something like, I don't know, we'll say 88, and I wanted to subtract another 2-digit number such as 15 from 88, right? You could do the traditional methods where you stack it up, subtract the ones and the tens. That's probably the most popular, efficient way, but this can give a little bit of a reason behind the stuff that visual learners can appreciate, right? So once again, we're going to do our number line, but this time, and this is what I would say. You'll see number lines look a lot of different ways, but most of the time in most curriculum, when it's a subtraction problem, they want people to see how the larger number is typically being subtracted by a smaller number. So it's the opposite with subtraction. With addition, the number that came first is on the far left, and you're working your way right. Well, with subtraction, the number you're starting with starts on the far right, and it's working its way backwards. So it's just reverse, right? Addition and subtraction, they're reverses of each other, inverses of each other. So it makes sense that we would do it a different way in a different direction. So if you look right here, 88 minus 15, remember 15, you got a 1 in the tens place. That's like the number 10. You got a 5 in the ones place. That's like the number 5. So it's like 10, plus 5. That's essentially what 15 is. So if I show this visually and I go back 10 to 78 as a beginning marker, I could say minus 10 since we're going backwards, we're subtracting. I like to say minus 10 when I go this way, plus when I go this way. But I'm going to minus another 5 because I got to get from here to the next thing. I'm going to minus another 5, right? So the question becomes 78 minus 5 more. What's that going to leave me with? I think that's going to leave me with 73. I just want to make sure I did that right. Yeah. And so wherever you end, you'll see the arrow at the very end of your line. That's where your answer is. And you want to emphasize that to your young learner. I'm just going to put that up on the board just so you can see it real good. Everyone see that? Okay. So this is just using a number line. It's another tool. And we just want to try it this week. Your kids are really young, especially if they're between the ages of 7 through 9, 10. You want to see what sticks with them. And maybe just to get the ball rolling, if they're having some stuck points, try some different things and see if, what luck you have. Don't get down if you try a method and they don't like it, they don't take to it. Especially when they're young, we want to give them grace to try different things. Just like, you try soccer practice, you try piano, you do taekwondo. Eventually the kid finds the thing that they thrive in, right? Same thing with some of these methods. So that being said, that's really all I wanted to say on the Math Made Simple side of things. It's straightforward, but I just wanted to give you another refresher there. Now, we also have people going through the final weeks of our Algebra Made Simple 8-week challenge, right? And I believe this week you're covering a special type of factoring process. It's called factoring quadratic trinomials. And there's lots of different examples I could pull from. I'm just going to see online kind of live while I'm doing this, if I can find maybe some more ideal examples real quick before I just make them up. I really want to be careful with this one. So let's see, trinomials. I specifically want to do the one where there's not really a leading coefficient. So give me just 1 second and I'll have a good set of examples that we can look through together here. I think I found it. Okay. So what do people do before the internet, right? So if you look right here, one of the examples that you're looking at, and I wanted to really start with, I don't know, I guess addition while we're getting things started. It's going to be something like this, where you have three terms, and I'm going to use the variable b this time. We're going to start with b squared plus 16b plus 64. Okay. You'll notice a pattern when you're doing these types where you have three terms called a trinomial for three terms, but the degree, meaning the exponent, the highest power there is two. We call that a quadratic trinomial when that occurs. Okay. You have to factor these a certain way if you paid attention to this week's material, and it's not by GCF. It's not by GCF. Why? Well, first off, there is no GCF with this kind of example, right? This has two b's, b squared. This has one b, but this last one called the constant has no b. It has no variable. So what do we do when that happens? Well, if you watch my video, I told you you want to find out what multiplies to with the constant term on the far right. Sorry for the glare. And you want to find out what adds to, it has to also add to the middle coefficient, right? And so one way you can kind of set this up so you can help yourself process information and think is to say, well, what two numbers do I know that multiply to 64? Start with what multiplies. Okay. Start with what multiplies. After you come up with your numbers, and there's several that multiply to 64, you could do 2 times 32. Check that. You could try, I think 8 times 8 is one. I can't even remember. I think 16 goes into it as well, right? There's a lot that go with 64. But whatever ones you pick, you then want to add the same numbers and see if it also adds to 16. Okay. It's got to check both boxes. If it multiplies here but doesn't add to here, then that's not the combination you want. And so you can try some different things. Like I said, you could try 2 times 32. I believe that multiplies to 64. But if I take 2 and I add 32 to it, does that actually equal 16 as well? Wrongo. It does not do that. So I think that adds to what? 34? That's not right. So this is kind of the process. There's some guess and check, or not guess and check, but there's just some trial and error. That's probably a better word. You could try 16. So what comes to mind for me first was 8 times 8. Okay. I'm really good with those perfect squares. So whenever I see doubles, that's usually what comes to mind for me. 8 times 8 is also we go to 64. So we just test it. Okay. It checks this box. It multiplies to 64. And if I take 8 instead of multiplying and I add them, hey, 8 plus 8 is also equal to 16. So that's my winning combination. Just so happens it's the same number both times. That's not always the case. Now, once I identify that 8 and 8 are the numbers that work here, I could have circled either one of those. Okay. The easy part is simple. You just do two parentheses, side by side, give yourself some space. And because the variable's b, it's b squared, you got to break apart b squared into what b squared is. It's really b times b. So you're going to put b in each parenthesis. And then, the numbers that you got, if they're positive 8, you're just going to say plus 8 and plus 8, and you're done. These are the factors of the trinomial b squared plus 16b plus 64. You simply leave them in these two parentheses, and that's how it is done. Okay, that's how it's done. Now, before we end it, I'm not going long today. I told y'all we're going to keep it pretty short and simple. We don't have too many topics to cover. That happens, but you got to use a little more thought when you have negative and positive numbers in your situation. Okay, so like for example, I'll use this one. Let's say you have n squared minus 10n plus 9. Okay, n squared minus 10n plus 9. I'm going to go ahead and put that on the board next. All right. Well, n squared minus 10n plus 9, think about it. This is not having a GCF either, right? There's nothing that goes into all three terms, but it does have those three terms. So we want to ask ourselves, in this case, what multiplies the 9 and adds, now watch this, to not just 10, it has to be a minus, or think of it as a negative 10 because of that minus sign, right? So once again, I like to do the little, blanks, fill in the blanks. What multiplies the 9? The same two numbers, if I added them, have to equal a negative 10. So sometimes that takes a little bit more thought when one number is a positive and one number is a negative, right? Well, the first thing that comes to mind for me when I see 9 is 3 times 3. That's just me personally, right? 3 times 3 does equal 9. It checks that box, right? But like I said, it's not good enough to just multiply to 9. It has to also add to 6. Well, that doesn't, that adds to 6. It needs to add to negative 10. Well, 3 plus 3 does not add. It's tired. It's Friday. It does not add to negative 10, clearly. So that means I have to go back to the drawing board because that first option did not check out. So even though it worked for one number, it didn't work for the other. Another option is 1 times 9. 1 times 9 is 9. And 1 plus 9, now watch this, It's tempting to pick this one because 1 plus 9 does equal positive 10, but we need it to equal negative 10. You see that? So what that actually tells me, when I got the right number part, but the sign's not right, that tells me I'm almost there. It's usually just a matter of changing the signs to my numbers, not actually changing the numbers. And if you think about it, if you know your negative rules, it's also true that a negative 1 times a negative 9 also equals positive 9, because a negative times a negative is a positive. And negative 1 plus negative 9 happens to equal negative 10. So once again, it checks both boxes, but it can take some more time because you got to think that through, right? Well, just like before, we got to have our two parentheses. If the variable's n, we're just going to put n in each one. And because they're both negative numbers, remember negative, think like subtraction. Negative 1 is going to be minus 1. Negative 9 is going to be minus 9. So this would be, really my answers are at the bottom here in the parenthesis portion. Okay. So just a little refresh of what we've been working on and what we were talking about this week, in case that kind of gives you a little pick me up refresher and gives you some confidence to finish strong. This is the Q&A session. Watch the replay. Hope it helps. Good luck this week. You can do it. I'm here to help. Good luck. I'll see you on the next one. All right. Have a great, great weekend, guys.